Hi dear students, we are going to continue with the finding the inverse of matrix, but this time we are going to find the n by n matrix, and we are going to use the row operations for this one. And this is the part that we are officially learning the row operations, because I already showed the row operations to you. Here, firstly, A should be n times n square matrix, and you are converting the A. If you remember, we were writing A and identity matrix together. Then we were converting the A matrix into identity matrix by using the row operations. When this becomes identity matrix, the B becomes inverse of A. So basically, if I show here A to A and I, we were writing together. Then we were converting this one to I, and when this converts to I by using the row operations, here the matrix becomes inverse of matrix. Okay, that's the basic rule about the inverse of matrix. Then let me remind you about the row operations. I told you before. There are three basic operations, elementary row operations. The first one, you can switch the rows places. The second one, you can multiply each row by non-zero constant. And the third one, you can add the row to another row. And as I told you, if you remember, k times rj plus ri becomes new ri. Here the letters may be small, but while we are doing the operations, you're going to understand better. Let's continue with new exercise, finding the inverse of matrix A here. This matrix is given, and if I explain basically about the rule, AI I'm going to write here together. Then I'm going to try to convert to matrix A into identity matrix by using the row operations. Then I'm going to get the identity matrix, and here this matrix, it's going to be the inverse matrix. So let's do this one. Firstly, here I'm starting with writing the matrix A, which is equal to 1 minus 1 and 1 0, and 1 0 minus 1 and minus 6, 2 and 3 it's going to be. So identity matrix, it's written here, which is equal to 1 0 0 0 1 0 and 0 and 0 0 1 matrix. Yes, this is the identity matrix, 3 by 3 identity matrix. Now I'm going to do some row operations, and I'm going to make here, by the way, I'm going to try to change this row into the identity matrix row. So I have to make the second column, second row and the third row entries, first entry is 0. To make this one 0, by using the first row, I have to multiply this one by -1, then I have to add to second row. Or to make this one 0, I have to multiply this one by 6, then I have to add, then this result, it should be equal to 0. But what I do for this row, I'm going to, when and add to second row, I have to do for all the entries one by one here. So 6 times, actually let's do first, minus R1 plus R2 is going to be new R2. This is the first one. And the second one, 6 times R1 plus R3. It's going to be our new R3. Let's do these operations here. Here, firstly, we are starting with the R2, and since we are not changing the R1, I'm going to write the R1 1 minus 1 0 here, 1 0 0. This row is not going to change, only R2 and R3 is going to change. So we are going to multiply the R1 by -1, then we are going to add to R2. So it's going to be equal to -1 plus 1, it's equal to 0. minus 1 minus 1 it's plus 1 plus 0 it's equal to 1. Minus 0 plus 1 plus minus 1 it's equal to minus 1. Minus 1 plus 0 it's equal to minus 1. Minus 0 plus 1 it's equal to 1. Minus 0 plus 0 it's going to be equal to 0. This is not going to change. Now I'm going to do the same thing for the third row, but this time I'm going to multiply by 6. 6 times 1 plus minus 6 it's equal to 0. 6 times minus 1 is equal to minus 6 plus 2 it's equal to minus 4. And 6 times 0 plus 3 it's equal to 3. And 6 times 1 plus 0 is equal to 6. And 6 times 0 plus 0 it's equal to 0. 6 times 0 plus 1 it's going to be equal to 1. That's the first operation that we did. Here, second operation, we are going to do this. For the second operation, I have to get the second one 1, then this 2 it should be equal to 0. To convert this one directly, I'm going to write the rules here. R2 plus R1 should be new R1, and R3 4 times R2 plus R3 should be new R3, because to make minus 4 0 by using 1, you should multiply the 1 by 4, then you should add, and the resultant matrix should be like this. I'm not going to change the second row, so I'm writing all the second row here, minus 1, 1 and 0. So directly add to row 1. 0 plus 1 it's equal to 1. It should be also like that. 1 plus minus 1 it's equal to 0. And minus 1 plus 0 it's equal to minus 1. And minus 1 plus 0 it's equal to plus 1 it's equal to 0. And 1 plus 0 it's equal to 1. And 0 plus 0 it's equal to 0. It should be. Till this part there is no problem. And 4 times R2 plus R3 it should be new R3. 4 times 0 plus 0 it's equal to 0. 4 times 1 minus 4 it's equal to 0. It should be 4 times minus 1 plus 3 it's going to be equal to minus 1. And 4 times here, 4 times minus 1 plus 6 is equal to minus 4 plus 6, it should be equal to 2. 4 times 1 plus 0, it's equal to 4. And 4 times 1 plus 0, it's equal to 4 plus 0, 4. And the last one is 4 times 0 plus 1, it should be equal to 1. Now this is the not last part, but after this operation, after 2 row operations, this is going to be identity matrix. How to get that one? Firstly, these are all have same signs, and this should be 1. So to get this one 1, I'm going to multiply the R3 by minus 1, and that's going to be new R3 for me. Okay, let's do the here operation 1 minus 1. These are going to be all same here. Actually, I'm using here this one. Then this is 0, 1, 0. I'm writing from this row here. Then 0, 1, minus 1, and minus 1, 1, 0. Here this is 0, 0, 1. It's going to be minus 2, minus 4, and minus 1. It has to be. So what I did, I multiplied the R3 by minus 1, and this is going to be new R3 now. Okay, now I'm going to do one more row operations by using the R3. R3 plus R2 is equal to new R2, it's going to be, and R3 plus R1, it's going to be equal to new R1. But I'm going to start the operation with R1. So here I'm going to do like this. Firstly, 0 plus 1 it's equal to 1. 0 plus 1 is equal to 1. 0 plus 0, it's equal to 0. 1 plus minus 1, it's equal to 0. Minus 2 plus 0, it's equal to minus 2. Minus 4 plus 1, it's equal to minus 3. Minus 1 plus 0, it's equal to minus 1. It has to be. So this one, it's going to be now R3 plus R1 is new R1, I said, and R3 plus R2 new R2. So here R3 plus R2, I'm going to add to R2 to find the new R2. 0 plus 1, it's equal to 0. 0 plus 1, 0 plus 0 is equal to 0. 0 plus 1, it's equal to 1. 1 plus minus 1, it's equal to 0. And minus 2 plus minus 1, it's equal to minus 3. Minus 4 plus 1, it's equal to minus 3. Minus 1 plus 0, it's equal to minus 1. It should be here. This is the last part now. I'm going to rewrite the here. This is equal to 0, 1, and then minus 2, minus 4, and minus 1 it's going to be. So, ladies and gentlemen, if this is the matrix A, and this is identity matrix, this is identity matrix here, when it becomes identity matrix, this matrix, it becomes inverse of the matrix. Okay, let's continue with the other theorems. Here, this is one basic operation. I'm going to explain this one. Then we are going to solve immediately one question here. If C is invertible matrix, then you can apply the following properties. It says A times C is equal to B times C. If it is invertible, then A is equal to B, we can say. But in which condition? If C has inverse matrix like this one. How to prove this one? A times C inverse. It's going to be equal to B times C inverse, you know. And here we can associate these two. A is equal to then A times C inverse. C times C inverse is going to be equal to B times C inverse, and then this is equal to here A times identity, it's equal to B times identity, and A is equal to B. It should be. You know, you remember it when we were talking about the properties of the multiplication, we told that this is not in general like this. In which condition it is like this? When the C is invertible matrix. So A can be equal to B in this condition. And for solving this question, we can use this property also. I'm going to use that property now. Here we are going to do like this. 5 times n plus 4n. If you remember, I said we can write the matrices in this form. 5, 4, and here then 6n, 5. Then these are m and n. We don't know what are they. And unknown terms. Then this is equal to 10 and 13. Yes. How to find the solution of this matrix? This is like A times B matrix. Actually, A times C matrix. This is now A times C matrix, and it's equal to A times X matrix, let's say, because this is unknown. A times X matrix is equal to C matrix. If I do like this, if I multiply both sides by inverse of the first matrix, like A inverse times A times X, it's going to be equal to A inverse times C. Then A inverse times A, it's going to be identity times X is equal to A inverse times C. So X should be equal to A inverse times C. So Mn, we are going to do this one now. Mn should be equal to A inverse times C, which is the 10 and 13. And then Mn it should be equal to, what is the inverse of matrix here? Let's find that one. A inverse is equal to, I can find the inverse here. Let me get these are here. And then A inverse with different color. A inverse here is equal to 1 over B times, here if you remember this is A, B, C, D. 1 over A times D minus BC times the, here A and D, they are going to switch their places, which is 5 and 5 again. And here 6 and 4, it's going to get negative sign, which is equal to like this. So A inverse, it's going to be equal to 1 over 5 times 5 times minus 6 times 4 times 5 minus 4 minus 6 and 5, it's going to be, which is equal to 1 over, this is 25, 1 over 1 minus 24. So 25 minus 24 is equal to 1 times 5 minus 4 minus 6, 5, which is equal to, A inverse, it's going to be equal to 5 minus 4 minus 6 and 5 it should be. So I'm coming to replace here. This is 5 minus 4 minus 6 and 5 it's going to be times 10, 13. Here I should close this one also, which is equal to here m and n. When you multiply these are, you are going to multiply 5 times 10, it's going to be equal to 50, minus 4 times 13, it's equal to 52. 5 times 10, 50, plus minus 52. So minus 6 times 10 is equal to minus 60, plus 5 times 13 is 65, and it's going to be equal to m and n. It's going to be equal to 50 minus 52 is equal to minus 2, and minus 60 plus 65, it's going to be equal to 5, which means m is equal to minus 2 and n is equal to 5, it has to be.